Now, as we have just discussed, that oscillatory motion is what? In which a body moves to and fro about a fixed position, that in which the motion is repeated after set of or particular interval of time, right? Now, what is harmonic oscillations? Harmonic oscillations are those type of oscillations which can be represented in form of single harmonic function. What are harmonic functions? Sine and cos. So sine and cosine are two harmonic functions which you know. So harmonic oscillations are those which can be represented in terms of single harmonic functions. So consider this wave and another wave. These two waves are representing equation of two harmonic oscillations. In this one, in both the case, this is wave versus time, or this is giving you instantaneous value of the motion at any point, let's say displacement versus time graph, right? So y in this case can be represented as amplitude multiplied by, this is a sine curve, sine of what? Sine of some set of frequency. I'll tell you what frequency is. It will be omega t. Similarly here it will be amplitude. Now what is amplitude? Times cos or cosine omega t. Now what are these terms and what do we call it as? See, first of all, what is an amplitude? Amplitude, consider the example of bob of a simple pendulum which is moving to and fro about a mean position. The maximum displacement which bob can take from the mean position is called amplitude, and it is represented here. That means this point, this is A. Same ways in this case B. So this equation becomes A sine omega t, or I can write it with even smaller letters, doesn't matter, A sine omega t, and this equation represented at B cos omega t. These two functions are representing two different harmonic oscillations because these both motion are represented in terms of single sine function or single cos function. So is that clear what is harmonic oscillations? When you can represent a motion in terms of single harmonic function. What if I add these two equations? My equation would be, let us say, y dash would be y1 plus y2, or I can write it as A sine omega t plus B cos omega t. Consider the graph, how the graph is going to be. The graph would something be like this, because when there is a minima and maxima overlapping, that means a positive energy and negative energy overlapping, there will be some disturbance in the peak energy, right? Similarly on the downward side, something like this. So this is called non-harmonic oscillation. So what is non-harmonic oscillations? Those type of oscillations which cannot be represented in terms of single harmonic function, because I have used two harmonic functions to describe this type of wave. Clear? Now there are some constants, some values which you should know about this function when we represent it. What are those? These are, first of all, I'll talk about this. This is amplitude. What is amplitude? This is the maximum displacement of particle or the body from its mean position. Then we have omega. Omega is called angular frequency. What is angular frequency? It is 2 pi by t. Now what is this new term t? This is time period. Time period is the time taken by the object to cover one complete oscillation. For example, I am playing in a swing. This is my mean position. Swing goes forward, comes back, goes backward and comes back. Now when it completed the going forward and going backward movement and coming back to mean position, this is the one oscillation completed, right? So one cycle is top 0, bottom 0. So this is called time period, time taken to cover one complete cycle. So this is time period t, and 1 upon time period is called frequency. It is denoted by this Greek alphabet nu. So what is frequency? It is the number of cycles completed per unit second. Suppose this type of equation or this type of representation is completing two, like from here to here and here to here, two complete cycles in 1 second. That means the frequency would be equal to 2. Simple. So 1 upon frequency is called time period, and omega, that is angular frequency, is 2 pi by t. So these are all the terms which are used to represent displacement versus time equation. So what is this term? This is simply time, right, which is in standard seconds, and this is displacement, which is in meters. So this is how you represent a harmonic oscillation.